For any quadratic function, actually we can say that the quadratic function will have three different items there. One item or one terms actually is the x squared terms. The second item or second terms actually is the x terms. And the last part, the last terms, actually is the constant terms. So in this function y equal to gx, we can see that 16k squared plus 8 actually is the terms without x, and that means this is the constant term. In general, for doing computing square method, we will mainly focus on the terms with x, such as x squared term and x terms. So the first step for computing square method, we will take out the coefficient of x squared from the first two terms. And then that's why the things will become 3 bracket x squared plus 4kx and then close bracket, and then plus the final item, that means the constant terms. We will do it this way. And then after we take out the coefficient from x squared terms, we will now only focus the thing inside the bracket. And then the constant term actually is something that in the coming sentence we need to always copy. So the meaning about computing square method is actually talking about adding some terms inside the bracket in order to make it inform as a perfect square. So actually, what is the things we need to add? We can always focus on the absolute coefficient of x terms. What that means is absolute. That means we only consider about the positive things. Even though the coefficient of x in this moment, even though if is a positive value, we will also think in a positive amount. And then that's why now the things we need to add inside the bracket is something about 4k and then divided by 2. And don't forget the name computing the square. Why we need to have the name about computing the square? That is because after we found what is the thing we need to add, that terms must have a square. And then based on the fairness of mathematics, we cannot suddenly add the thing to the function. And then that's why when we add 4k over 2 bracket square to the function, we need to do some compensation, for the function. And then that's why we need to minus 4k over 2 bracket square. And then now we say that this function is fair, and everything is just like the previous sentence. And then after you finish your computing square, you add the square to the thing inside the bracket. The thing outside the bracket, which means the constant terms, you still need to copy. And then now we can discover the first 3 terms inside the bracket, they are already in form of the perfect square, which means they are already a square. And then this time is plus 2ab and then plus b squared. And that's why actually the thing inside the bracket, the first 3 terms inside the bracket, can be already write down in a square format, which means x plus 2k close bracket and then square. Even though the first 3 terms already become perfect square, but the yellow color, that means the biproduct, the compensation, we still need to copy. And then actually we can simplify a little bit about the biproduct, which means 4k over 2 is 2k, and then bracket square, so that's why it's 4k squared. And then now we almost go to the last step. Because there is a phi outside the bracket, we do some basic simplification. We can still distribute the phi inside the middle bracket. Okay, so that's why phi now is going to time x plus 2k bracket square, and then phi are going to also multiply for the biproduct, minus 4k squared, and then that's why the thing will become minus 12k squared, and then together with the constant term from the very original. And then we can observe the thing minus 12k squared and plus 16k squared, plus 16k squared. Actually, they are the like term, so that's why we can just do a further simplification. And then the result will become phi bracket x plus 2k and then bracket square, and then plus 4k square, and then plus 8. And then now the quadratic function already from general form become the vertex form. And then based on this vertex form, we can write down the vertex of the quadratic function easily. Okay, actually the vertex based on this format will be equal to minus 2k for the x coordinate, and 4k squared plus 8 will be for the y coordinate. And then that is the answer for question 16a.